No one talks. No one talks. Look up. Okay. Apologize. The quiz questions took a little bit longer than usual. Okay. So the things like everyone. So the things that are happening repeatedly, you've got to make a note of that. Like if there's a concept that you're like, man, we just keep asking about it every single time, you got to come talk to me. Like, I'm asking you to have faith in my comment that if you're not really following what's happening in class, the test score is not going to be like 70. I'm being very serious about this. The test score is going to be like 35. Okay, it's AP Calculus. It's a college level class. What a lot of people don't realize, look at me. Like I'd like you to vote on something. Okay, just your perception. So there's not a right or wrong answer. Just give me your perception. Okay, this means, well, let me give you the question first. It really, I'll just tell it to you. The perception in high school is this. If I come to class, I will pass the class. To me, that's the perception that most people have in high school classes. That is absolutely not true in college. The only way to pass a college level class is to show competency at a reasonable level. Like you just won't pass. And colleges and universities are perfectly happy to accept the current rate's about $1,000. The $1,000 you will pay to take that class and have you fail. They're perfectly happy to have that happen. So part of what I'm trying to get you to understand and get you used to, I'm trying to do it in as gentle and patient a way as I possibly can, is that you've got to change your mindset from, oh, I come to class and I do my homework, to I've got to make sense of the ideas. And if I'm not making sense of the ideas, I've got to keep asking, and if we kind of run out of time in class to ask, I've got to find time outside of class. So I felt a little bad this morning. There was somebody who showed up at about 7:37. Looked like they wanted to ask a question, but that's a really bad time to ask a calculus question, because you don't answer calculus questions quickly, because otherwise it doesn't help you. You've got to talk about the problem, make sure the concept is making sense. If you're looking for a class where you just learn steps, you are in the wrong class. This class is not about learning steps, it's about understanding. So anyway, I'm going to try and come earlier, send a text and told everybody, just so, because about 7:30 is about as late as I can go on questions. Because then I got to start getting ready for class, and I felt a little bit bad about that. So anyway, okay, because we spent so much time on the quiz, we don't really have a lot of time to hit homework very hard. There were only 8 questions. Is there anyone who was specifically prepared when class began to ask a specific question from the homework? Yes, I'll address it. If not, we won't worry about it. So you got 25. Okay, so first thing, okay, I want to, like I only got paid focus and participation tickets for all, so I want to get back to that. I want to try and pay that today. So look, somebody just talk through how to solve it. You don't have to tell me every step, just tell me one step, I'll write it down with you. Factor. Okay. In calculus, factoring isn't always what you want to do, but in many cases it is. So even on problems where you're not even sure what to do, factoring is a good place to start. So Dawson says we need to factor this. Come over here. Somebody factor the numerator for me. Oh, Mary.
X minus 7, X minus 3.
Nicely done. And somebody factor the denominator for me. Let's go here to Connor.
Take out 4 and then X minus 7.
Well done. Okay, on the next line, I'm going to divide these because that doesn't really cause me any problem. I'm going to leave the X minus 7. I found a lot of people who keep, I hate to use profane language, but they keep saying cancel, and it's causing them to get mixed up. They don't cancel, they don't go anywhere. They're just there, okay? But what you should remember is, if I plug any value in for x, what will this become? 1. Other than that one special value for which this does not become 1, which is 7, okay? Just keep track of that. Don't lose it. It's still there. But for most things, we don't really have to worry too much. This is going to equal 1. And so I look up here and notice that, oh, they want me to use this to find every single y coordinate. Now, David had a good comment when class started. Something really clicked for him. He noticed, we're not doing this, he noticed that, let's see, if I want to find values, put a negative 100. So we get a bunch of people to get the participation ticket today. So I just need a volunteer. So all you have to do is raise your hand and answer a series of questions, and you're in on the participation ticket. There you go, Kenna. So I take 100, right, negative, and I want to find out what the y coordinate is. So I put it here, here, and here. This one's easy. What will this become? 1. And so let's see, 1 times 1/2 would be a half. If I put a negative 100 here, what will this become? Very good. So it's just negative 103 divided by 2. So let's write 103 over 2. So Ken is in. Question? Oh, please.
My only question was that, like, why are we still plugging in? So, sorry, kind of going back to like 25.
Sure.
I plugged in a 7. Why could you plug in a 7 if it says that x specifically can't equal 7?
Oh, hold on that thought.
Okay,
Good
yeah.
question. Perfect. You're doing great. Somebody do negative 90 for me. I'll pay you as well. Jake, what do you get?
Negative 93.
Very good. Somebody do negative 80, so you can get it on the participation ticket. Ethan? Negative 83 over 2. Okay, the point I'm trying to make is this. You can choose any x you want, and you can find the y value easily and quickly. And there'll be a nice sequence of values. They'll all be like close to each other if you're picking x values that are close. So it's perfectly continuous until we get to what David was talking about, and that's when x is equal to exactly negative 7. When we plug in exactly negative 7, we don't know what the y value is. Oh, positive 7, thank you. So we plug in positive 7, we don't know what the y value is. But that's fine, they told us we wouldn't, because they said don't plug in positive 7. But the function is supposed to be continuous. The function cannot be continuous if you don't have a y value here. You have to have a y value here. And this y value has to be really, 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 really close to this y value. Whatever that is. It has to be infinitesimally close to that y value. Otherwise, not continuous. That's the big idea. Questions? So how do I find these two? Plug them in. Yeah, you can plug those in just fine. So somebody else who wants to take a just answer a serious question, Ryan? So if I plug in just a little bit less than 7 here and here, what will this become, Ryan?
1.
1. Genius. What does this become?
About 4.
Really dang close to 4. Use old-fashioned language. Really dang close to 4. 4 times 1/2 is really close to 2. So Ryan's in. Somebody 7 plus needs another volunteer. So let's go here to Tessa. So put the 7 plus here and here, Tessa. What does this become? Becomes 1. Put the 7 plus here. What does this become? Really close. So this is really close to 2. So I need, when x is equal to 7, I need this to be 2. Therefore, this needs to be 2. To make sure it's continued.
I am confused why x minus 7, like the middle part, why that's 1.
Oh, gotcha. So just do a little experiment for me.
Okay.
Put it 10 here and here, and what does this become?
3.
Over,
Over 3.
which is 3 divided by 3.
1, okay.
There you go. All right, does that answer your question?
Yeah.
No worries. Good work. Anybody else? Good work. Kesty gets an extra ticket too. It's hard to ask a question you feel like I should know, right? Isn't that fair?
Yeah.
Like it's hard to say, I should ask because I should know. But you just got to keep asking.
Thank you.
Good work. Okay. Next thing. Okay, so the homework tonight, come on. The homework tonight is problems 26 through 47. So this is really the rest of the pink packet. Okay. Something you'll notice about those problems right away. You scan through it. Every one of those problems is from an old AP test. If you're curious, I actually document which test so I can look it up later if I need to. This was 1985, number 41. 1988, number 41. That's a while ago, but I guarantee you I looked very closely at what's being tested today. Like I spent a long time doing this, hours and hours, looking at what's being tested like last year and comparing it to what was tested long ago. And things that don't get tested anymore, I don't show you that, okay? But things that are being tested, the same concepts, I like use those old problems to help you. Okay, a couple warnings about tonight's homework. Okay, I gotta see eyes on this one. Okay, if you do this while you're working the homework tonight, you are wasting your time. Like it's just a total waste. Don't read the problem and say, I'm not really sure. Let's see, 26. Okay, I see. The answer is E. Oh yeah, that makes sense. Got 26 done. Okay. You laugh because you know that that happens. You laugh because you know it happens. Things are only funny if you can relate to them. Okay? That's what all comedians do. They find something you can relate to and that makes you laugh because you relate to it. Look. Okay. Okay, let me give you a couple things about the AP test. First of all, when you're working on an AP problem, please get used to the following feeling. Get used to the fact that you're going to read the question and you are not going to know what to do. Okay? Contrast that. No, look, come on, contrast that. Think about other classes you've had. I feel pretty safe in saying that most classes you've had before, when you read the question, your mind just goes, oh yeah, I've done this before, and then you just do it. Okay? That's not AP calculus. And it ain't real life neither, so to use interesting grammar. Okay? No one will pay you anymore. There's no jobs for this anymore. No one's going to pay you to do something that's already been, well, I guess there are certain jobs that are repetitive. There are. But to me, I'll just express my personal bias. An interesting career involves doing things that are different, like new challenges, things you have to figure out. You're not given problems you've done before, you're given new problems. And you have to reference what you've done before to answer the new problem. So anyway, in this class, when you see a question, just get used to reading it and not knowing what to do. It's normal. It's totally normal. So what you do instead is, instead of just quitting and saying, I don't know, nobody pays you for that either. Okay? You tell your boss, I don't know, about 4 times, he's like, I don't know why you should be here either. So, okay? I'm being serious. You have to do something, okay? Look, so when you read an AP question, like here's how I would do it. It's okay, the limit as x approaches a of the function is equal to L. There's a comma, so I stop. And I say, I'm not sure what that means. They gave me this information, let's keep reading here. L is a real number. Okay, that's fine. So there's, A is a number, L is a number. They're just values. They don't give me the numbers, but they're just numbers. This is which of the following must be true. And they ask a bunch of questions. Okay, so what you need to do right now as a class, talk to each other, but we need to come up with, like, what is this telling us? Like, when you read that, your brain has got to pull from it, like, things you know about what limit means. So that you can somehow write something down that means the same thing as this. So feel free to talk to each other for a minute, ponder it, pray, whatever. Okay, like, just raise your hand when you can tell me something. What is this telling me? The limit as x approaches a of a function is L. Ken is ready. Please.
You know that x is
Hey, listen, please. Listen. Go.
So you know that x is going towards A, but you know it's never going to get to A because it's going to A, but it'll never actually get there. So you know it can't be A.
Pause right there for 1 second. You're right on track. Everything you're saying is perfect. You're remembering perfectly. And when you're finding the limit as x gets close to a, you're like, oh, but that means x is never going to be a. Okay, so they're saying when x gets close to a, so somebody else jump in now. What does it mean to say that that equals L? Like to say when x gets close to a for the function f, we get an L. What does that mean, Nate?
That's what it's intended getting close to the rest of the y value.
Very good. So we know the x coordinate is exactly what Ken has said. It's not a, but it's close. We know the y coordinate, not at x equal a, but close to x equal a is going to be L. Can somebody suggest another way to write that down? Because you can write it in a different way, form, picture, graph, or something. It often will prompt a memory, and then you can solve the problem more easily. I'm trying to show you how to solve pretty much any AP problem. So somebody think about it. What's another, Dawson?
Could be like kind of the end behavior.
Good idea. M behavior is slightly different, but you got the right idea. M behavior really refers to x approaching infinity. So we're not really doing that at this point. Not a bad idea. Like, how can I represent what has been said? X is getting close to a, the y coordinate's getting close to L. Go.
Maybe like less than or equal to something? Like you do like x to a to L, and you do like.
Oh, gotcha. Good idea. Slightly different idea as well. So you're thinking more, no, stay with me. You're thinking more of like an interval, like from here to here. And we're not really talking about an interval. We're talking about x being almost a, and the y coordinate being really, 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 really close to L. Other hands, come on, come on. Let's compare this time.
Would you put the
Table.
X and Y?
Table is a good way to see it because all of you are more comfortable with tables. Like, come on, somebody answer this. Get it on the participation table. For how many years have you been using a symbol that looks like this? One hand, come on, somebody talk. For how many years have you been using this symbol?
This year.
Thank you. It's meant to be a stupid question, okay? Yeah, she's like about 3 days, a couple of weeks, right?
Yeah.
Okay, Blake, please. Just a quick estimate, for how long have you been using something that looks like this?
Before I can remember.
It's been a while, like several years, right? It's been a while. That's the point. If I write it like this, your brain's going to be more comfortable. So let's translate, hey, come on, come on, come on, focus. Let's translate what this means into this. Somebody help, come on. Ethan.
So would you just put like really, really close to 7? I mean A.
Yeah, no, I used to. The quiz had 7. So.
Yeah.
So yeah, so somebody help Ethan. Hey, what symbol do I write down that means really, really close to A? Right, please.
A minus.
A minus. Keep talking, come on.
L minus.
Oh yeah, and honestly, I don't really know what this is, so I just know it's really close to L. It could be exactly L, I just don't know. What else do I know? I hear a voice. Schizophrenia.
9, sorry.
No, keep talking, Blake, it's good stuff. A plus. What else do I know?
That's
Close to L. Okay, look at me, look at me. Look, look, look. Okay, when you're talking about continuity, notice the magic word. There's the word continuous in here. When you talk about points on a graph, this helps me a lot. Okay, this one in the center, this is at exactly x equal a. As Ken has said very nicely, we don't know anything about what's happening at x equal a. But we know a lot about what's happening a little bit to the, this would be your right, my hand. A little bit to the right of a and a little bit to the left of a, correct? We know what's happening there, so we just wrote it down on the table. Okay, so when I see a limit, I know about 2 points. Okay, but I don't know anything about this, because the limit isn't telling me what's happening here. So be with me. Perfect. Okay, there's a symbol. I need somebody to raise their hand and get this one. There's a symbol. Okay, to represent this point, there's a symbol I use. I can do it like that. Or on the quiz, we talked about how I can do it like this. Okay? That represents this point, right?
Yeah.
Good. If I do the other one, like this. That represents this point. Dawson, please.
was it the same as number 9, that equation that we wrote?
Yes, that's exactly right. Well, it's related. It's related. It's not exactly the same, but we're very related. It's number 8, actually. No big deal. I'm a bit obsessive. Sorry.
Wait, it was 9. It was
I
number 9
thought
on
it
the
was 9.
I thought 9 was the
Well,
13.
because like the one that.
It was number 9.
Seven,
It was 9.
I thought it was.
It was number 9.
I'll trust you. Moving on. Okay. Sorry. I'm mixed up. The class is right. Don't listen to me. Okay. Look, hey. The key idea is this. The key idea is this. Hey, look up. The key idea is this. This is referring to one point. Like, really, get that memorized. This is referring to a different point. Okay? Just say it out loud, please. How many points is this referring to?
1.
3.
Well, no, 3.
3.
2.
2.
That's not something to A.
Thank you, Blakely. Look. Look, this kind of helps, like really. Hey, look, this one, hey, these two, right? It's hard to hold your hand like that. Got it?
But it is telling you the 1 point. You just have to infer that there's more. That's why we add the positive.
Yes, correct. You have to infer. This really is talking about 2 points. I'm not doing the middle one. Okay. Funny joke. All right. Never mind. Look. Yeah, never mind. Moving on. Look here. So this is referring to 2 points, right? Left and right. I need to make sure that you all know a symbol that represents this value. Like right here. What symbol can be used to represent this y coordinate? We got to know that symbol. It's got to be like stuck in your memory permanently. So you guys ideas? The triangle we use to represent change. That comments something has changed. No good answer. What symbol specifically? Now look. What x coordinate goes here? A. Okay. The symbol you need to memorize is this one. Okay. If the x coordinate is A, the y coordinate is f of A.
Okay.
So let's go over here.
Well, duh.
So look. Once again, this problem has no value if you don't understand every little concept associated with it. Because I guarantee you something. The AP test writers are so good at writing questions that once you understand this problem, you'll never see it again. Like, they do not ask repetitive questions. They come up with a new way to ask the same concept. So what you have to get good at, and what's going to help you in your future career, I guarantee it, in college as well, is like you learn everything you can about this problem, and when you encounter a new one, you say, oh, wait a minute, it's AP Calculus, I'm not supposed to know what to do, that's normal. So you start remembering things. You start writing down those memories, and pretty soon you'll put them together and you'll solve the problem. So here we go. F of A exists. If somebody explain to the class, what does it mean to say F of A exists? Come on, hand. Let's go, Dawson. It's an actual point. So if F of A is undefined, Dawson, does that mean F of A exists or doesn't exist? It doesn't exist. So if F of A is undefined, it won't exist. Somebody answer this. They're telling you that the limit equals out. Are they telling you something about F of A, yes or no?
No.
They're telling you nothing about F of A. They're only telling you about these 2 points. So do we know whether F of A exists? It could, but it might not. The question says, which of the following must be true? So it ain't that one. Because F of A could be a value, but it might not. Please
How do
read
you
it.
know if it is?
Oh, they have to give you other information. Great question. Listen to Brianne's question. They'd have to tell you, F of A equals such and such. That would work. Or maybe they say this, Brianne, and this goes back to the quiz. They tell you up here, they say, oh, this function F is continuous. Okay, look at me. As soon as they say F is continuous at x equal A, you think of this. And you say, I now know all 3 points. Because to be continuous at x equal A, this value's got to have a y coordinate, and these two have to have the same or very similar y coordinates. Is that your question? It's very good. Is everybody okay on A? Somebody talked about whether B is true or false, and why. You have to know the reason why. Just wait here. Somebody will see it. be true or false and why? Stretching, trying to decide what I really want to ask. Again, just wait a second. Somebody else here. Paris is in. Somebody else knows. Dawson here. Jake this time.
Well, it's kind of the same idea as A. If it's continuous, it means you'll have an X and Y coordinate. That's if you're not sure.
Very good. Let me say it back. It's perfect, Jake. He said, if the function is continuous at x equal a, somebody answer this. If the function is continuous at x equal a, what does the y coordinate at x equal a have to be based on the problem we're talking about? L. Do we know what the y coordinate is at x equal a? We do not, because all we know is the limit. So that's why that could be true, but it could be false. Good work. Question. Welcome to the AP class. Okay, serious. This is just how it goes, every question. C, f of x is defined at x equal a. Somebody comment on that. F of x is defined at x equal a. Mary, please.
It is defined kind of similar word for standard points.
Perfect, perfect. This really is exactly the same thing as this one. Like A and C are the same thing, just different words. It's classic AP test writing. They come up with a question that just uses different words to test you on the same idea. So Mary said, well, if I don't know the y coordinate when x is a, I certainly don't know whether f is defined at x equal a. That's where the word undefined comes from. And we don't really know, so it could be true, doesn't have to be true. Somebody comment on D. Go, Paris.
It's true.
Tell me why.
Because f of a equals L.
A little circular, but that's okay. So they're asking us if this is true, and she says it is because it is. But that's just so. Help me, Rich.
I would
Stop
say it is
asking.
because it could have a little bit less than A equals L, a little bit more than A equals L, then A should equal L.
Okay, listen to Rachel's comment. It does fit with Paris's really well. Look, okay, what Rachel just said is true if you have a continuous function. If the function's continuous, then the value at x equal a has to be really close to these other two values. And since these other two values are close to L, the value at a would also have to be close to L if the function is continuous. Does the statement here tell us that the function is continuous, yes or no? No. So we don't know that for sure. So good comment, very good. And that's kind of why Paris answered the way you did, is because they're leading you down this path, and they're trying to trap you into a wrong answer and say, well, don't we know that that has to be L? We don't, unless they give us some other information. So this one doesn't have to be true either. It could be, but we don't know. So this is the correct answer. Question. Awesome, next one. 33. So we're just doing a few examples. And you'll attack the rest for homework. And example is really the wrong word because every problem is different. It's the AP test. It's like I'm trying to help you understand how to attack AP test problems. So here we go. Look, with the graph of this, so that's just a formula for finding xy pairs, so I don't really stress about it. So if the graph of this formula, this function, here's the keyword, has a horizontal asymptote at y equal 2. I believe I've told you, if I have, I'm pretty sure I've told you, you've got to make sure this is memorized. As soon as you see that a function has a horizontal asymptote at y equal 2, you should immediately be thinking the following. So cross this off so we can use this for notes. You should be thinking to yourself, oh yeah, that's right. That means the limit as x approaches infinity of this formula, ax plus b divided by x plus c, that limit's got to equal 2. That's what horizontal asymptote means. So as soon as you read that, you should be writing that down. Okay? I'm not showing you how to solve the problem step by step. I'm showing you how to solve any AP problem. I don't know how that's going to help me, but I recall from memory what I know about horizontal asymptote. Okay? So agree with me. Please.
Why is that equal to as a person thinking?
It's really no different than saying, like, don't take this wrong, but really it's the same idea. Why do we call this a table? Because that's what it is. It's the same answer. It really is. The word horizontal asymptote means exactly the same thing as what happens to the function when x approaches infinity. Why does it mean the same thing? Because somebody decided that it would. Like, I'm serious. They said, we're talking about a function here, right? And we can see that as x approaches infinity, in fact, let's keep talking here. Somebody help. As x gets bigger and bigger and bigger, what's this formula going to do? You guys have done limit problems before. Help, please, come on, hand. What's this formula going to do? Is that, need a hand. What's the formula going to do as x approaches infinity? Got these guys, get somebody new. Don't stop raising your hand. It helps me that you raise your hand so I can kind of see who's got it and who doesn't. Let's go back to Ethan here. Will depend on A, as far as whether the top gets bigger than the bottom. There's something I can guarantee you regarding just these two terms in the top. Good answer, Ethan. Hey, somebody, come on. What can you tell me about these two numbers as x gets bigger and bigger and bigger? Nathan?
But you know, AX should be bigger than B.
Yes, because B is not going to change. And x is going to grow and grow and grow. So I can say, hey, this is equal to this. What can I do on the bottom? Gets close to x. What does that get close to as you plug in larger and larger numbers? No. You plug in 100 here and 100 here. What's that going to equal? Hey, what are you plugging in 1,000 here and 1,000 here? What's it going to equal? Hey, plugging in 1,000,000 here and 1,000,000 here. What's it going to equal? A. It gets closer and closer to A. So, somebody said the answer is A. The big mistake you made there is you're not thinking through the problem. You're back in a previous class before AP Calculus where like you didn't have to understand what you're doing. You just had to figure out something to do, and then all of a sudden the answer appears. No. You gotta understand what you're doing. The answer will not appear. Okay. But I learned something. It goes back to David's question. Okay. If you find the limit of a function as x approaches infinity, we found that this value will get very, very close to A. That literally means if you're making a table, and you let the x-coordinate grow forever, when the x-coordinate gets really, really large, the y-coordinate is going to be very close to A. That's what limit means. Question? But equal means same as. Means these things are the same. So if this limit's equal to 2, and we kind of ignored the 2 for a minute, we found out that this limit's equal to A, what's A equal to? 2.
Wait, can you repeat that?
Yep. So look up here.
Yeah.
Look at what I'm going to circle here. We said that this limit is the same thing as 2.
Yeah, because they equal each other.
We were able to say that because we know what the word horizontal asymptote means. The word horizontal asymptote means the limit as x approaches infinity is going to be the value of the asymptote. That's simply what it means. You've got to memorize that. But then we said, hey, knowing how limits work, we know that this red thing, that's why I put an equal sign here, is the same limit. So the limit of this problem is the same as the limit of that problem. So, Kesta, if this limit's equal to 2, what's this limit equal to? 2. Has to be. They're the same thing. We figured out that this limit's also the same as just A.
Yeah.
So that means the A has to be 2 as well.
Okay, yeah, you just keep simplifying it down. Okay.
Question? Please,
How
go.
do we figure out those limits are equal to?
Are you comfortable that these two things are the same thing? Okay? Are you comfortable because x is going to get really, 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 really big? When you add these two things together, eventually you won't notice that you're adding b. Therefore, whatever this limit's value is, it's the same as that one. So if this limit's value is 2, so is this one. Good there? Perfect. But we also can logically conclude that if, let's see, if I plug in 1,000,000 here and 1,000,000 here, it's going to be 1,000,000 times A over 1,000,000, that's just A. So it doesn't matter how big x gets, this is just getting close to A. So A must be 2. Perfect. The rest of the problem says, there's a vertical asymptote at x equal -3. We gotta remember what vertical asymptote means. Say it.
The number over zero.
Vertical asymptote occurs when the x coordinate produces a y coordinate that is a number over 0. So that means when the x coordinate's -3, let's try that here. So we put in an x coordinate -3. So we go a times -3 plus b is supposed to be, let's see, -3 plus c. And Blakely says this is supposed to end up being a number over 0. I know what c is. What's c? 3. Okay. Okay, look, tonight, every question is different. Every question is going to probe your ability to say, I don't know what to do, but I can use what I've learned to start writing things down, and then I can figure it out. So good work. Any paper, take it quick. So focus and participation.
That was 9. So it needs to be 70 minus 9 equals 9. 18.
Test it. Got it. And see it.
Stop asking. Class TC? Yeah, it's like this is like a line. You got to do to solve the problem. It's not like
Because like there's a miscommunication.
I'm not saying that I'm going to teach myself. I legit feel like I'm the
Good job.
I really don't want to like iterate, but I'm just like, okay.
Job,
I'm gonna be the first one.
Job,
Okay.
Jessica.
I'm
stay
not
for a little
paid.
bit during your prep period.
You can stay for a
I
minute.
said that long ago.
I can't typically do a lot of helping during my prep,
Okay.
because otherwise I never get anything done. So, but you can stay for a minute.
So like how long?